I hear static.
I don't know much about that part. The western part, I can tell you, but the middle part.
Yeah. You don't want to be in the middle part. Well,
Australia is like everything wants to kill you. You got the deadly spiders and the jellyfish.
The flies will eat you in Cooper Petty.
Yeah. You been there? Go. Even though
Study the Opal from a lot.
oh, the snakes. They got bad snakes. They got everything. Crocodile. Yeah. Madeline.
How are we doing?
Yeah, this is better, but let me check one more thing. Is this mic on at all?
Shark.
Do you know? Oh.
There you go.
So let's
Try that.
Did you make it?
Well, they told me my This is the strength we're going to talk about. Some people think that sociologically it's really bad to live underground for so long. So we'll talk a little bit about what that's like. And I wonder if I can get rid of that. I bet you I can. Yeah. Okay.
Well, why don't you get started?
Okay.
One way or another, we'll figure it out.
Yeah, because some of you have kind of a time constraint on you. So we'll go ahead and get started. Now, we're going to talk about opal and mining opals, and what it's like. And the vast majority of the opals in the world come from Australia. And there's 2 locations in Australia that have opals. And the number 1 location that we're going to talk about is called Coober Pedy, right? Coober Pedy is actually Australian for white fella in a hole, okay? It's from the Aborigines, and we'll talk about that in a little bit. But 80% of all of Australians' opals come out of this one set of terrains. And when we start talking about that, we're going to kind of show you where it's at, what the conditions for living there are like. And so when we talk about the interior of Australia, it's a desert. These are the 4 major deserts, but there's a little sandy desert over here, and another desert here, and another desert here. The vast majority of people who go visit Australia are right down in this little corner right here, all right? That's where all the big population centers are. Now, Coober Pedy is such a strange place that they didn't even have a road through to it, a paved road, until 1987, even though they've been mining opals there since 1916. So here's Sydney and Melbourne and Adelaide and all those places. So here's where the major populations are. But as soon as they put this last road through in 1987, it became a tourist destination. Okay? People suddenly wanted to see what it was like to mine opals and live underground. The worst thing about this is this road from here to here kills more people than any other road in the entire world. And the reason is, it is so boring they fall asleep and they drive off the road. Okay? And there are markers about every 4 or 5 miles saying one person died here, another person got injured here. And they mark all of those locations to try to keep the people and say, take a break, because it's about a 400 and some mile drive. People think they're going to make it, and they just follow across the road. And that is why it's the most dangerous stretch of road in the entire world. More people killed per mile. Now, when you get to Coober Pedy, okay, now this slide takes a little explanation. Okay? When the Mars rover got up there and they started sending the images back, the editor of the local paper said, that's right. So he went outside and he took these pictures and then wrote the headlines. There's really no place like home except on Mars. So this is the newspaper headlines the day the rover images came in. And look how similar Mars and Coober are. Okay? Because it is a true desert. These light color in seeing First of all, it's all in sedimentary rock bearing land. This upper layer right here is deep red sandstone. And we go over about 30 miles away from the town, there's an embankment in which a big desert storm beginning to sweep across the town. Shall we continue, or did you want to take a little break here and try to get reestablished?
Hang on.
What's that?
Hang on, if I can restore the sound. Then, okay, they have the sound but no video, so at least, yeah, let's keep going with the talk.
Okay.
And I mean, they see the presentation, so I'm going to try to work on the video.
Now, we're going to talk a little bit about a climate. A desert climate requires very little rainfall. So we really have to look down here at the precipitation. That's less than 1/4 of an inch a year. Okay? Now, I lived in a desert, and it got 9 inches a year, and it's still classified as a desert, okay, in the Southwest. People think that it has to be really hot, but the largest desert in the world is actually parts of Antarctica because they get so low of precipitation. But this one has fairly cool readings in July. Now you think that's July. We're in the southern hemisphere, remember? Seasons are reversed. So our winters are their summers. So here's our winter. Their highest temperature is 118. Average temperature is 94. The big thing is very little precipitation. But it's going to be cold enough that you're going to want to heat the place in the winter. And it's going to be hot enough in the summer that you want to air condition a lot. Okay? Correspondingly, people have decided to move underground. Now, here are some of the advantages to living underground. First of all, it's a constant 75 degrees. Suddenly you lose your heating bill, and there's no cooling necessary. It's the same temperature all the time, 75. The other thing is that the big storms have very little effect. You're underground, the big storms roll right over the top of you. So almost 60% of the residents of Cooper Pedy live underground. Now, the cost of construction is about the same, even though it looks a lot different. So here's a typical kitchen in an underground home. You know, you got refrigerator, you got electricity, you got, it doesn't look too bad. It's just that when you look at your walls, it is all rock. All right? Now, if you happen to be living underground and as you're constructing your house, you happen to find an opal vein, you are not allowed to turn your house into a mine. But you can go down to the local city hall and put in a permit for an extra room. Okay? So there have been a number of people who have said, oh my gosh, look, over here is an opal vein. Let's add an extra room that direction. Okay? So you are not allowed to mine your own house, but you can expand your own house. So that's why they're living underground. Now, the reason it became a tourist destination is that people began to say, let's go up there and live underground. So they began to have bed and breakfasts, hotels, museums, churches, bars, everything underground. So here is a typical bed and breakfast. Here you can begin to see these little pipes, which are for bathrooms and living rooms and other things for ventilation. And so you would park. This is the down-to-earth bed and breakfast. And you walk in, and then you walk down a big hallway, and you enter the actual residence. Now, talking about opals, because we want to talk about opals at the same time, and we're beginning to show opal pictures in here. Opals have what they call opalescence, the really valuable one. If it shows opalescence, it's called a precious opal. And what that means is that it's an array of colors. And the colors will change based upon changing the light around, change the angle of viewing, okay, as you rotate them around. And the color seems to come out of the interior. And at some point you may see red, flashes of blue, flashes of green, and Coober Pedy opals are precious opals, and they'll show you all of those colors. And we'll see if some of these are not projecting very well, because we have a very good play of colors on my screen, but it looks like a gold vein on your screen here. And we'll see if some of those will project a little bit better in a minute. So, living underground. Here's the Desert Cave Hotel, the realization of a desire to share extraordinary underground living in the sense of, sounds like a good advertisement, right? They have your own rooms, each of them is underground. They have a main lobby, okay? So you can go there and live underground for a while. They have underground churches and museums. Here, this one projects a little bit better. You can see the opal play of colors. The most valuable color is actually a red with a little bit of green, okay, and then blue. And then, if it changes its color as you rotate it around, and you get both, at least 3 different colors, it becomes very valuable, right? So, we're underground churches, underground museums, and if there is a bar, what the heck, this is Australia, all right? So there's underground bars as well, right? And you can see the rock everywhere. Now, when we start talking about living in Coober Pedy, you can get postcards. The postcards of the weather, all right? We're going to see some postcards that you can send for the mining areas, but this is the most popular postcard to send. When you turn it over, okay, it says on the other side, "Hi, Mom, I slept here." Okay? So this is what it looks like on the surface where most people are living underground. They still have to have ventilation, so those are rooms. See all of those pipes and everything? All these people are living underground. How are we doing? No connection yet?
No. We saw the audio, and we're trying to mess with the video.
Okay.
Okay, let's keep going.
Okay. Now, so why do they want to go there? All right? We already said that it's Aborigine. It means it translates more like white fella in a hole, right? And that's where the term came from for the city, Coober Pedy. They have mine tours, okay? So they'll take you down and let you walk through the mines. And this is the shape of the horizontal shafts that follow the opal veins, right? And the Coober Pedy hat is even popular now in the United States, and they're selling these, okay? So it's a real rugged place to be, and I'm going to... more for an opal than you can for a diamond. Really good opal for its weight. Now, mining don't think very well. When we start mining, the way we're going to mine these opals is they're going to dig vertical holes in the ground. They're going to go straight down. The opal layer is down. That's all your claim is. You drill the vertical hole down 80 feet, and as the material comes up, you pile it up around the hole, and you search through it. If you got opal, you've got a mine, right? So then you're going to go down inside of this hole, and there are so many holes, right? There are 2.5 million holes in the ground in the greater Cooper Pedy area. And so wherever you walk, there was an exploratory hole, exploratory hole, exploratory hole, no mine. Okay? Here was a mine. He went down, and now he's going horizontally, 80 feet below the surface. He's going horizontally, following an opal vein.
They have to do this, or are there any geophysical means?
We'll talk about some mechanization here in a minute, okay? Because
Kind of wildcatting there.
it is. It is. And when we start to mechanize, it's going to be real low-level mechanization as well, okay? The veins all run out, okay? They don't last very long, but they're just honeycombed through the area. So it has not worked out well for big mining operations to just level it like strip mining of coal, right? It would not be economically productive to move all of that stuff for the small amount of opal that you would get, okay? So each mine starts with a vertical hole. When you want to become a miner, all you have to do is you have to go in and register, and you get a fire, or you get an explosive permit, and we'll show you some of the things. But Mike Rowe arrived in Cooper Pedy on his show, Dirty Job, went down and registered right away and became a miner, okay? They checked this to make sure he wasn't a terrorist and gave him an explosive permit, and then gave him 50 meters that he could dig on as much as he wanted. Now, when you start, your prospecting shafts are made by using this Caldwell drill type thing, and it just spins around, pulls up dirt, goes down about 6 feet, pulls out dirt, goes down about 6 more feet, pulls out dirt, and you can make an initial hole that's maybe this wide, all right? But if you think you're going to do something underground, the maximum width that you can get on it is about 6 feet, okay? So some of those holes are 6 feet wide, and they are down 20 to 80 feet to the opal-bearing layer, okay? And this is just the exploratory place. Now, when we talk about earth science and geology, they tell you there's 3 types of rocks: sedimentary rocks, igneous rocks, and metamorphic rocks. And some of you are probably in these classes. But there is a 4th type of rock that they hardly ever tell you about in an introductory class. And those are called hydrothermal rocks. They are rocks that have been altered by hot water solutions. Hydro, meaning water, thermal, hot. And so hot waters from deep in the interior of the earth can actually flow through, and that's where we get really interesting stuff, right? We get gold veins, silver veins, copper. Most of the materials that we mine are actually altered, one of the 3 main types of rocks, and we call them hydrothermal rocks in the veins themselves. And we quite often don't get enough time in physical geology to teach that, but it's a very important concept because that's where my opals are coming from. We are going to see right here that this is all layered rock, so I'm in sedimentary terrain. We've already talked about the different layers. Yet, at the same time, sedimentary rock can have things like fossils in it. And here's a clam fossil, and right through the center of the clam fossil, it's been hydrothermally altered, and I make opal. Opal is not a primary deposit of the sedimentary rocks around here. It has that hot water solution, when the whole region was deeply buried, permeated the area. Now, the hot water solutions found porous levels inside of the sediment and soaked along those porous levels rather than moving up and down. So quite often, when you find an opal horizon, it's right inside of the sedimentary rock. And you're going to follow it along for a while, and then it's going to become unporous in that sedimentary rock, and your opal horizon is going to stop. All right? So here is one of these shafts that has been put down. All right? And we're going to go down inside of these and look for an opal layer. Now, here is an opal layer right there. See the opal right across there? Right? It's right inside of the sediment. It's a layer that was more porous, and so the hydrothermal veins went through and altered everything. Right? So they're in horizontal beds. So when you first drill your 80 things, you check the dirt that you pull up, and if you see opal laying in there, you've got a mine. Now, 85% of the vertical holes produce no mine, right? So let's say you pull up a little bit, you spot some opal in it, and you say, okay, I'm going to go down. So they now lower you down, and you start your horizontal shaft. And here is following an opal vein. Most of the time, the opal's not a huge horizontal sheet. It's just a small piece, maybe 20, 30 feet wide, horizontal, and you start off following it. Now, you're going to have to hand pick all of this, right? And so you're going to have to stand up in there. So these horizontal mining tunnels are called drives, and they follow opal seams, right? And you're allowed to go off your 50 meters underground following an opal seam. You're only allowed to explore your 50 meters on the surface, right? If you find nothing on the surface in your 50 meters, that claim's dead, right? So now, some of it is really rudimentary. So, largest opal mining region in the world. If you wish to look for it, you need to get a mining permit, requires criminal check, and then you get your 50 square meter claim. And some of these people, here are explosives, there's dynamite, and there's, okay, and some of them are very low tech, and he's following some, right? But he can make a living doing this, and sometimes these people can make a really good living. But a lot of people at the same time want to go to mechanization. So when we mechanize, right, now this guy's not doing what it looks like he's doing, okay? He's got a little ladder here. He's unmechanized. He has mined the opal, put it in a bucket, and he's pulling up the bucket like by the hand, okay? And that's his hole. You want a hole that's bigger. Remember, we said you can go up to 6 feet across. Since 85% of these claims have no produced opal, claims are small, mines follow linear seams, they may divide. No big company's ever going to make any money off of this. So if I do mechanize, even the mechanization is going to be relatively small. So I'm going to try to lower something down inside of this 6-foot diameter hole that will be easier than hand picking all the time. So here's a little cartoon that shows you how they're going to do it. All right? Here's the vertical hole. All right? Here's the drive going off this way. We're going to lower this little thing here that's only going to be 5.5 feet across. All right? So it'll go down the hole. We're going to lower it vertically, and it will have different types of gears that we can put on the front that'll churn up the rock, and then we'll suck up the stuff. It'll come up this thing up here and into this truck, which puts a vacuum on it and sucks all the debris out, right? And he's got to dump what he calls his waste basket, and he'll dump all of that material in there. When it gets full, he's going to pull a little lever, and we're going to find it all gets dumped, right? Now, he really is going to get all of his opal directly out of the wall by hand. This is just to get rid of the waste. So if he's following a little seam and he sees it right there, he's going to run this underneath, and then he hand cabs all the opal very carefully because he doesn't want to crush it, send it up here, and have all that opal crushed because opal's not very strong, right? So let's show you a little bit of the mechanization. This thing that's actually in the front is called a bogger. It's a front-end tunnelling machine. The Opal, I still have to do by hand. Now, here's a bogger, right? So here's some of the Opals. A thumb and a finger. You can't see, so he's holding them like that. That's probably, if it's really nice, Cooper Petty white Opals, it's probably worth maybe $1,000 right there. Okay? So here's a little bogging machine at the end of the tunnel, right? And he's going to take away all the waste. And right here, you would put it inside, and he's got a very flexible hose. It's like, and so that if he drives further down, it stretches and stretches and stretches, and all that stuff goes out the back. All right? They turn on the machine at the top, okay? And here he is making a drive. Here he is lowering the bogger down the hole, right? So he's increased the size of his hole to 6 feet. Here's the ground surface, and you're taking the picture straight down in the hole as they lower the bogger down to the drive, right? Here's the flexible shaft on the back. He's lit up the front with his bogger, and his drive is going that way, right? And that's how come when the tourists come and they see these things and they walk down, they're perfectly circular, right? This one has been done by mechanization. And this one has got a big blade on the front. It's just cutting because he's lost his vein. He's hoping to come across another vein. So you have different things you can put on the front of your bogger. But you put on big lights. This is a light. That's a light. And so you're lighting up the end so you can see the iridescence of your opal, right? Now, as you continue along, right, in here, we are going to show you the real pictures of that diagram. We're going to start over here, right? This diagram here, number 1, okay? So it shows you that here we're going to turn a 90-degree corner. Down there's the bogger, and they're sucking out the waste, right? They're hand carving the opal that's mined directly in there. The waste goes around here, turns the corner, goes up your 6-foot hole, right? It's going to come up into this truck, right? It's producing the vacuum on it that sucks all that material out. The material goes up and into your dust bucket. When your dust bucket's full, you pull on the end of it, and all of that falls down in that pile right there, right? So it's going to come from tip of the mine, around, up through the hole, up into there, into your dust bucket. You're going to pull it out, and you're going to get a pile of waste. These are called mullet heaps. Right? I'm not exactly sure where all these terms come from, right? But we have seen that there are mullet heaps all over inside around all of those holes. Now, look at the mullet heaps. Now, these are real mines that have paid off. 1 in every 85. Mullet heap, those are real mines. Look at the mullet heaps across there. Each one marks a productive mine. Right? So they stretch for miles and miles. Look at this one, which is a little bit higher. You can see mullet heaps, right? So they go on for miles. Now, most of those are not currently producing. Most of those have been productive mines in the past. They've run out, and then they go get another 50-meter permit and do another one in another area. Now, here's down 62 feet. The guy's over here. He's driving towards what he called the color trays. Okay, they put in another hole over there so they could suck the waste out, not because it's too far over there. So he's got another claim to the right, and right now he's got a little bit of what they call color, right? And so here's just another hole that was unproductive. So holes everywhere in the landscape. They have now, so many tourists have walked in there, fallen into the holes, that they have now made it illegal for you to walk through the mining area unless you go with one of the miners. And the miners take you on tours all the time for a small fee. All right? And so here are all the mullet heaps. Here's a productive mine, but look at all the holes. 1, 2, 3, 4, 5, 6, 7, 8, 9. plenty of holes that were not productive running all through the area. 85 times more prospect shafts than mullock heaps. Okay? Now, one of the things that the tourists like to do is that as soon as you mechanize and you're having all this stuff hooked up and it comes running out, is that you're going to miss some opal. Remember, you hand carved that opal, but if you're on that little bogger and it's turning around, so this is called noodling, right? Here's what they're looking for. They're looking through the mullock heaps to look for missed opal. And so as a tourist, you can pay, and on a given day, you go down to a mullock heap on a mine that's currently working, and you can usually find 2 or 3 pieces of opal. Okay? Now, the opal is not that valuable to the miners because they're following the main theme, so they charge you like, $25. And you'll find 2 or 3 pieces of opal for your $25, and maybe those 2 or 3 pieces of opal are worth maybe $30 or $40, right? So you become a noodler, right? You go out and you can become a professional noodler, okay? Professional noodlers go through old mullock heaps. This is a professional noodler's little mining cabin. Let's show you how it works. He hauls this over to an old thing, he pulls it in, puts it up, drops it in, and he runs it down a conveyor belt. And he's looking for opal that the miner missed with this little bogger in the front. And so these noodling machines. Now, one of the characteristics of opal is that when you put an ultraviolet light on it, it glows. All right? So he'll have a little section in here in which all of the material's going by, and it's got a big black light over it, right? And the opal is fluorescent, and if it glows, he picks those little pieces out. And that's enough for him to make a living. He gives a small share back to the miner who made the mullock heap, right? And he's a noodler. So here is opal fluorescent. It's white and long UV light, and so there's a little piece of opal here, there's a little piece of opal up there, right? And he's just sitting in there in that little beat-up old bus, okay, in a little dark area, and he's got a UV light, and he's running all the mullock heap through, right? Now, we're going to talk a little bit more about opal. We've already said that it's made by silica-rich hot water solutions that follow these porous layers. A lot of opal that's in Mexico follows old ash layers from volcanic eruptions, right? In the Australian area, this sedimentary layer is almost pure fine-grained quartz. So quartz has the formula of SiO2, and so when the hot water solutions went through that pure quartz, right, that was fine-grained, it took some of the silica off the edges of the quartz, and it redeposits it back. And you can go through and it replaces existing minerals. Here is a big calcite shell, right? The original calcite shell was made out of calcium carbonate. But now it has been completely, okay, well, some portions still might be calcium, but the cracks inside of the shell, the hot water solutions went through the cracks, and so here's calcium carbonate, and there's opal. All the opal filling all the cracks inside of this shell. And this is a very nice museum piece, right? Has had the molecules inside of the shell replaced along the cracks, right? This is hydrothermal alteration. Now, what causes the color, right? People think normally when we talk about colors, we're talking about the metals that are on this section of the periodic table that's kind of set down a little bit. And those metals cause color for the most part, okay? And so if you have quartz and you add a little titanium to it and a little bit of iron, you can turn it to amethyst. You add a little bit of nickel to it and you can turn it to citrine. And we just take ordinary old quartz and add lots of those little elements called chromophores, okay? And they are contained right there in the middle from 3 through 12 on the periodic table right there in those columns. But that's not the cause of color in opal. In opal, it turns out that there's a very symmetrical array, and that right there is a little ball of this quartz, silica. And between it is water, right? So I have lots of spheres of quartz that are microscopic, and this is a highly, highly magnified view. This is not even a microscope. This is kind of a very high-tech electron microscope to see this level. And here are small spheres that are nicely arrayed. And depending on the size of the spheres, it will take in white light. Now, white light is named after this famous guy, Roy G. Biv, all right? And when it comes back in here, Roy is actually red, orange, yellow, green, blue, indigo, and violet, right? So Roy G. Biv is all the rainbow colors. As it comes back in and it goes through these spheres, it will diffract it just like a prism does, and you can get red, orange, blue, green, indigo, violet, all right? Roy G. Biv colors coming out. And as you rotate it around, so here are the larger spheres bring out the reds, and those smaller spheres bring out the blues when they diffract, right? So if you have a collection, here's a water molecule, right? So we're talking real small spheres of silica, SiO2, 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 all right? So there's the sphere of silica. Here's the water molecules in between them, right? And this is a highly magnified view of what an opal is. Now, let's see some of these. Boulder opals, okay? Now, boulder opals, you actually get to see the rock, and that's why they call it. And the veins usually run through, and you turn this over, and you got the rock attached to the back. With the loose sedimentary opals, the loose sands of Cooper Petty, I'm going to have what we call the crystal opals or the white opals. These are in some ways the most valuable because they're usually pretty thick. These are the black opals. The black opals are pretty much confined to Lightning Ridge, which is on the other side of Australia. So black opals and crystal opals are the dominant opals that come out of Australia. Now, when we start talking about the most common jewelry production styles of opal, we can synthetically mess with materials, and we don't have to say that they're not minerals, as long as we haven't completely made them synthetically. Okay? For instance, if you find a beautiful topaz ring and it's bright blue or London blue or any one of those other blue colors, when it was found in nature, it was probably yellow. And they put it in and they heat treated it. Very few blue topaz crystals are found in nature. Most of them are yellow, and then we heat treat them. All we did was heat them up, right? And it changes the color. So they don't say that that's synthetic. They say that's still a natural topaz crystal. So to actually say it's synthetic, you have to make it at the atomic level and grow it in a lab and let it grow from a solution. Now, we can mess with opals a whole lot and still call them natural opals. The most common jewelry production styles that we're going to talk about as we start to decrease the value. If you have a solid opal like that from Cooper Petty, right, it's going to be worth a lot. And the light's going in, and it's a big solid piece, maybe, a couple millimeters thick, right? But there is such a thing as common opal. Common opal means that you've lost some of the water between it, and the water helps to hold those spheres in a nice array. So if I get to common opal, I lose all of the color flashes. No opalescence in common opal. Some of the common opal, it'll even turn black, and it's called a layer of potch. So what they'll do is they'll take a layer of potch, the black opal, and then they'll take a real thin slice of the iridescent opal, and they'll put it on top, and that's called an opal doublet. This, one of the ways to turn a nice white opal into a black opal. People like the black opals with the dark look and the dark color. Most of those are doublets, right? In which I've taken potch, I've put a black cement on it, and I've taken a tiny opal slice that's only, since the opal, the color is only coming out of the top millimeter, right? I only need a millimeter slice, and I cement it on there, and those are called doublets. They are required to tell you when you buy an opal, whether you're buying a solid opal, a doublet, or a triplet. Now here's what a triplet is. This opal slice, opal is real, it's real soft. You don't want to have opal in a ring like this, all right? Well, I'll pass this ring around. This is a Cooper Petty, but it is, unfortunately, it's solid. So it's scratched. That opal scratched to heck when you look at it, okay? If you want it in a ring, you're going to want to put a third layer on the top, and you're going to want a layer of pure quartz or something on top of that. Something that's really hard, that will really protect it. And those are called, right? Those are called triplets. You're going to put another slice over the top of something to protect the opal. So now, as you synthetically fiddle with this opal more and more, you're losing more and more value. But you are not necessarily losing better color. All right? This is a triplet, and it's a gorgeous triplet, but it's only about less than a millimeter thick for the layer that is making all the color. All right? Now, we could go to the internet opals and start looking at these. All right? Here's your triplet. Here's your cap of clear quartz. Here's your tiny opal slice. Here's the black cement. Here's the potch underneath. And look, opal. You just have to say opal triplet. Opal triplet. The opal slice is in the middle. So here are what people consider black opals, right? Because the black potch makes them real dark and blue. They got beautiful fire as you move that around, just like when you move the ring around, you're going to see that the colors, that one has reds and blues and greens, I think, and it's mostly reds and greens, right? Okay? Okay? So it still has the opalescence, it still has the fire, and they look great, and it is a very relatively inexpensive way to get yourself some nice opals. Nice opals. Let's try the slicing machine. So remember, we were showing you these people taking out opals that were about this big, crossed like that, and about that long. And you say, wow, that's not going to produce very much. Once they put it in the slicing machine, look, this slicing machine right here has 220 blades. It is going to slice things to the level of a millimeter. Here are big pieces that have come out of the slicing. Here's material that's going to go into the slicing machine. Right? So that's how we're going to make a whole lot of money. Or that's how they're going to make money off of a little piece like that. They are going to run it through till it's millimeter-sized slices, and then they're going to make doublets and triplets out of them. The really nice big pieces they'll sell as the solids, right? And so even small pieces become valuable. Now, if you're curious about what it's really like, this guy at Internet Opals, okay, has a blog, and he walks you through every aspect, as a good Australian does, with a nice twang to his voice. And his blog, you can just read it, and he will take you through like 4 years of his opal mining in a daily blog. And he tells you about all the stuff that he does, and it's a step-by-step, and he's got beautiful pictures of all of his operations. Okay? And so if you want a copy of this PowerPoint, we'll make sure you get one. All right? Now, So, if you're going to go to Australia and you decide to go to Coober Pedy, right? Right? Do some noodling with the locals, right? Anyway, go out there, right? Find a bullock heap in the background, right? And live underground, right? That way you get to stay out of the dust storms, right? And the dust storms will come, send me a postcard. Thank you. I'll answer any questions you might have. Yes?
Were there any reports of earthquakes on the
No. It's way in the central area. It's real stable in there. Okay?
So is it safe to live there?
Oh, it's very safe to live there. Mm-hmm.
What
Yeah.
about earthquakes if something happens?
What's that?
What about earthquakes or like
Oh, actually, when earthquakes occur, those waves that go by don't crush all the rock around you. The only place that the rock actually breaks is along the fault where the earthquake is, and then the rocks just transmit the waves. So you would be perfectly fine in an earthquake there, okay? Because you would be very stable above and very stable below, okay? And the earthquake wave would just... The reason most buildings fall down is because you lose vertical. And as the surface wave goes by, the building tips, right? But underground, you don't have to worry. I mean, maybe you get your chandelier swinging a little bit if you had a nice underground home. But it'd be very stable. It wouldn't collapse on you at all because you'd have all the earth supporting you all the way around. So earthquakes wouldn't be a problem, but this is still in the continental interior, and it's away from all the plate margins, so you wouldn't be getting very many earthquakes. Other questions? Oh, thank you. Yeah. Yes.
I purchased a space opal from a jewelry company.
Uh-huh.
It's mostly silica. It's blue. Do you have any idea how they make these synthetic opals?
Well, there's several ways to make the synthetic opal. A lot of the times, they can take crushed up tiny pieces of aluminum foil and put them down inside of there, and then put a coating on those that will cause the color to reflect off the little foils. And those are very inexpensive, okay? If you actually try to put in microscopic things that'll diffract, like the bubbles, then those opals are synthetic, but they're much more expensive.
Okay.
Okay?
Here's a question. How deep underground were those homes?
Oh, the homes, they are generally less than 20 feet underground, just enough for good insulation. Okay? They would be not much more than a big, deep root cellar or something like that. Okay? And most of them all have doorways. Of course, you have to get out, so you have to have a doorway to the surface somewhere, right? And so they're built on the side of a hill, and so they go back into the hill, right? You don't have to go down a set of stairs to get into your house. Other questions?
I was just wondering, since you showed that little marsupial there in front of the hole, how much wildlife winds up falling into the hole?
They say that the wildlife gets killed because of the highway coming to the thing compared to the hole. Okay?
Yeah, the holes that are moving, they figure out where they are.
Yeah, they can figure out where they are. But they have a lot of roadkill because there's no fences, there's no nothing, and so there's a lot of roadkill along that entire highway. It's considered the most destructive highway in the world right now. For not only human life, but...
So this area was hydrothermally active at some point in the past.
Yes.
But not
Not like geysers, probably. It was probably so deep that the hydrothermal fluids were maybe 200 or 300 feet or more down, thousands of feet down. Okay? And since then, the continent is lifted, and we've eroded it down. And in some places, that's how they found it. They eroded some embankments, and they found the layers with the opals in them on the surface first, and then they started following those underground.
was there like a feature there?
There are a few faults, okay? but very few of them are producing the major opals. Major opals are on the horizontal in the side of the sediment itself.
So horizontally, go outside your 50 square meters?
Yes, they allow you to go beyond your 50 square meters on a drive. And there are supposed to be some conflict.
Well, that's what I was asking. Undermine literally someone else.
Usually everybody knows where everybody is, okay? And so if they're coming from that direction and you're going from that direction, that's when the conflict appears, okay? Okay, yeah. Well, that's the same way. You don't have to be really deep. For instance, petrified wood. Most petrified wood is under a fairly shallow layer of ash. It's at the bottom of the layer of the ash, and even the rainwater dissolves the silica off the ash, and by the time it gets down to the bottom layer where the ash is sitting on the ground, okay, it can actually flow along there and take carbon cells out of the wood and replace them with silicon and make petrified wood. So you don't have to be real deep, okay? Silicon dioxide.
It doesn't have to travel very far.
It is actually dissolved in the water.
And then it redeposited.
It redeposited, yeah, as spheres. Mm-hmm.
So it seems like, I think gold is actually transported by water too, right?
Yes, gold, silver, all of those are transported. Gold's usually,
Does that go much farther?
those can be, copper, for instance, can be taken from a real large area of miles and miles and miles before it gets concentrated into a few veins. We're now mining copper and we're hardly even following veins. We're following disseminated copper that is so, when you look at the ore, you can't even see the copper in the ore anymore. It just looks like rock, okay, because it's so disseminated. But that was all hydrothermally deposited by hot fluids flowing through the region.
Colorado, energetic, copper mineral.
Right.
Colorado, did I say Florida?
You said Colorado.
I didn't say Colorado.
Any other questions? Sure.
So the spheres have to be in a regular array.
Yes. When they're not in a regular array, they're still opal, but they don't cause the diffraction. They'll still have the characteristics of the opal's hardness, the opal's fracture, but they won't cause the color. And those are called common opals. Now, you have to be careful with opal because you can take a really nice opal, leave it in the sun, okay, on a shelf, and the heat from the sun alone will drive the water out, and you'll start losing the fire out of your opal. So you need to take good care of opals. You know, don't leave them any place hot. Don't. Okay.
So over time, will any opal dry out?
No. It has to have a pretty high temperature to drive the water out. Or do you?
I've heard of people keeping them in water.
Yes. A lot of collectors keep them in water. Okay. Mhm.
Oil up surface.
Yes. Mm-hmm.
It's a seven precious.
Any other? Yes.
How long does it take for the formation of the rock to form?
When we're talking about geological things, we don't think in the regular terms. Like a short interval for us is 1 million years in geological terms. Okay? In social terms, that's a long time. So when we start talking about events in the geological past, we'll say that happened between 30 and 35 million years ago, plus or minus 5 million years. All right? So these are real slow processes. Okay? And we just hard to think about these processes. Geological time is an entire way of thinking. It requires a quantum jump from social time.
So where should we go collect some of them? Here.
Precious or semi-precious?
Any kind of opal.
I don't know of any opal that you can collect in Georgia.
Well, it's hydrothermal activity, or there was in Franklin County.
North Carolina?
Yeah.
There's some of the, yes. We can get some opals in Tennessee and North Carolina. There's a couple places where you can collect opals, but I'm not aware of any place. And if you want nice fire opals, you're going to have to go to New Mexico. You're going to have to go to the Southwest. Arizona, Colorado has nice opals. Okay? Yeah. You can stay at my house because one of the big opal fields is only 30 miles from my house in Colorado. In Colorado. It's one of the big opal fields is only 30 miles from my house. Yeah.
Is there any advantage other than jewelry you can make Opal?
No, it's pretty much just jewelry. Opal's not really used for anything else but jewelry. Okay? A lot of minerals have very specific properties, like diamond. I can use diamond not only for jewelry, but it can grind. It's a good abrasive and it'll be polishing. But opal doesn't have any characteristics other than jewelry.
What's the most they've ever found for an opal, like dollar value?
I would hesitate to say, but some of those samples, when I was looking at them, were like $6,000 to $8,000. Okay? But they say that some of them, carat for carat, are going to rival diamonds. And diamonds can get up into the millions. So I don't know of any opal that requires millions, but they are valuable. Yeah. Okay. Oh, sure, I can do that for you. Anybody else need a little signature for their class? I'll do those right now. Any other questions?
Thank you.
Uh-huh. Good.
That's good. Thank you.
It's kind of interesting. Did I steal your pen? Oh. Okay. Oh, where do I sign? Right there? Okay.
The ring. Your ring. Did you get it back? Yeah, just wanted to show it.
A lot of times they won't project in the camera, but you can try to rotate it around very slowly and see if the colors change. Okay. Well, the PowerPoint worked just fine.
Thank you, Dion. That's great. I love your enthusiasm. It's very contagious.
Yeah, well, let's give them a different idea of geology sometimes, you know, to do this stuff.
Wonderful.
Uh-huh. Yeah, it is. Yeah.
Yes.
You know, when you put an image in PowerPoint, if you have it on it'll run.
Yes, yeah, because you run that directly and the computer ran so directly. So you can just click on the link